So for this question, we're determining the age of zircon that's found in a fossil. And this geologist finds that carbon-14 and nitrogen are found in there. 60% of the sample is nitrogen. Determine the age of the zircon. So if we go back to our steps, step one, we have to look at the table of elements for radioactive dating. So we use this table to find our isotopes. So you've got 5 parent nuclides to choose from, and then the corresponding daughter nuclide is on this side. So this is the final decay. So in the question here, it talks about carbon-14. So if we scan our list, carbon-14 is one of the parent nuclides. The daughter nuclide is nitrogen-14. So now we have to figure out what's the percent of the parent. So we identify parent and daughter. So this is carbon-14. And the daughter is our nitrogen-14. And we also need to know what percent of the parent is remaining. So if we go back to our question, she finds 60% of the sample is nitrogen. So in this case, we have to subtract from 100. Nitrogen's the daughter. I need to know what percent of carbon. So sometimes the question will give you the percent of the parent. Sometimes it'll give you the percent of the daughter, and you just subtract from 100. So 100% minus 60% equals 40% carbon-14. Then we want to look up the half-life of carbon-14 in your data book. And it is 5.73 times 10 to the 3. Okay, we use our chart now to figure out what percent, based on having 40% remaining, how many half-lives have passed. So if I look at this chart, 40% is right here. And if I trace over to here, it's approximately, I would estimate that to be maybe 1.4. It's not quite 1.5. 1.5 would be right here. I would estimate it's about 1.3 or 1.4, maybe 1.3. We'll go with that. Okay, so we figure out how many half-lives have passed and what is the half-life. This tells us how old the sample is. So I take the number of half-lives and I times it by the half-life of the parent. Okay, this will tell me the age of the fossil, or in this case, the zircon is a fossil. The number of half-lives that have passed is approximately 1.3, and the actual half-life of carbon is 5.73 times 10 to the 3A. Remember, A stands for annum, which means years. When we multiply this out, so 5.73 times 10 to the 3 times 1.3 gives us 7,449 annum per year. Okay? We only want 2 significant digits, so I need to use scientific notation here. Remember when you move your decimal to whoops, technical fail here. I love you, Toscu. That's in the recording.
Love you more.
All right.
Thanks
So,
to Brad.
all right, for scientific notation, guys, remember when you move to the left, your exponent is positive, right? So this becomes 7 point, I only want to use the first digit, 4 times 10 to the power of 3, because I moved it 3 spaces.